I want to design my shear tab. So you have your beam in your staff, right? And so this is your column. And this is the beam. And this is my shear tab. So your shear tab, I think the project statement says it can be 2 angles or 2 plates. But doesn't matter. So essentially, if you can imagine it, I have one angle that goes like this. So one face of the angle is on the beam web, and the other face of the angle is on the column flange, right? So what's some of the important things here? First of all, I have 2 angles, right? It's important to make sure the length of this angle doesn't exceed this distance. So if I look at the beam section, you have something like this, right? So you want to make sure the length of that angle doesn't exceed that, right? So that's important. Then you go, to SAP for that member. You know what's the VF. So essentially, the analysis is done on the center lines, right? But it's fine. You can just get the shear diagram from your SAP, or your VF would be the maximum shear on that member. So that's your VF. So you have to amplify VF, amplify VF to account for load eccentricity. How? It's mentioned in the project statement. You just multiply VF by factor, right? When you do that, now I want to size my bolts. So you can assume that you use 3 bolts. Let's say you assume 3 bolts. Then you can say, okay, VF divided by 3, that's the bolt capacity that you need. So you can choose 1/2 inch bolt or 3/4 or what have you, right? Just make sure that is more than the capacity. You may find that the capacity of the bolts is much, much bigger than what you need, but that's fine. Use at least 3, okay? And after that, you also need to connect, also, how many, in the design of the bolts, I have 2 shear planes, right? I have 2 faying surfaces, because I have one angle, the web, and another angle, like this, right? Makes sense, right? Then you also want to design the weld here. So the weld from the angle to the column, or from the plate, could be also a plate. So you have one weld on this side, one weld on the other side, right? That's also easy. So you know the size of the weld, the length of the weld, and you get the size, right? Okay, so that's shear tab design. The more important one is gusset connection design. Are there any questions about this? Also, important, I forgot. Be sure to check block shear cases. Block shear cases on page 361. So make sure for the shear tab design, make sure you check those block shears, okay? So So essentially what could happen is that it could break like this. So that's a block shear check for the end. Okay, now let's look at gusset plate connection. So I have my column. So gusset plate connection design is a little bit more complicated, but I'm going to explain. Don't take a video. Just remember. I think, and there's nothing wrong with that. I think COVID, including myself, made us a little bit used to certain resources like videos. It's important that you go back to, you know what, let's say you're in a meeting with your boss, you can't take a video, right? You can be like, oh, just listen. Take notes. Anyway. So gusset plate connection design is a little bit more complicated, but I'm going to explain a simplified version of it to you that's based on the general procedure that we can use in the course. So the design process is a combination of calculations and also geometric design. So essentially, what we have done in our model, in our SAP model, our analyses are based on the center lines, right? So if I do the center line of my column and my beam, they would meet at a point that I call the working point. So that's the working point. Now, it's, like I said, it's a combination of drafting and calculations. So what you've done is that you looked at your brace. I think the detail of the brace, so I'm drawing the brace and I'm going to draw it horizontally for a reason. So my brace is the brace that I've designed is a W section, right? And I know that W section brace is going to somehow connect to here with a splice plate. So that splice plate would look something like this. Again, I'm going to make sure that splice plate is not wider than this. And I'm going to make sure I put enough bolts for the capacity of the load. And I also have to make sure the spacing requirements are respected, the edge distance and the end distance and all those things. So I have this already spaced out, right? So let's do the same thing on the other side. Let's say our gusset plate starts somewhere here. So I can leave like a 5 millimeter to 10 millimeter, 5 to 10 millimeter gap here. And I know my gusset plate starts here, right? And I can do the same configuration on this side. What's the good thing about it? The good thing is that I no longer have to check spacing or bolt size and whatnot again. Right? So it's the same as that. And this is my gusset plate. But I don't need to draw the gusset plate now. So I go into AutoCAD or any drafting program that I have. I select all of this, right? Also, this working point, there's another working point on the other end, right, in my game. So I draw a line from here to that working point, which goes to the other node, right? You see what I'm talking about? So essentially, we're looking at this. So I go from here to that other end. Then I select all of this in my AutoCAD. I rotate it such that this angle or this line would line up with this. Right? I rotate it. I rotate this and I bring it here in my AutoCAD. And then I bring it close to this end. So my slice would be somewhere here, let's say. And I, leave some gap here and or here. One of them would cover. So you don't want it to be too close. you want to leave 2 inches here, right? Right? Then I have these lines already drawn here, which, like I said, it's you can leave like anywhere from 5 to 25 millimeters. I said 10, but it doesn't matter. Gap between your beam and your gusset. Then you go up and you go up and you go perpendicular to your beam and column, so perpendicular. And here, depends on how much room you have here. But again, this length can be anything between, 1 inch to whatever, 2 to 3 inches. Depending on the room that you have, right? But this is a general procedure, okay? In real practice, when you design for compression, you only learn to do connections for tension. In real practice, it would be a little bit different, but the general thing would be the same. Also, you also have the option to have a weld here instead of bolts, but I think that would be more boring. I think this way, you do the spacing once and the bolt, capacity, and then once you have this drawn, after you do all this spacing and whatnot, you bring it in AutoCAD. This is already in AutoCAD. You rotate it such that you get the same angle here, right? And you move it until it gets close to these ends with a reasonable distance. Then you go perpendicular to the splice, and then perpendicular and perpendicular, right? Okay, so yes. No,
what's the gap between the plate and the beams?
This gap
To the left.
here. There's no gap.
Now.
Oh, this one. This can you can bring it to 1 inch, half an inch to 1 inch. But one of these would cover. So essentially when it could be tilted more like this. When the bay is bigger than the height, you will see that this would cover this distance. And this you just have to anyway.